the grand organic chemistry. So we done unit 7. Last week we started unit 8. Under that we have hydrocarbon and halohydrocarbon, and we did the very first part, hydrocarbon. Under hydrocarbon we have alkane, alkene, alkyne and benzene. So last week we finished the alkane part, and today we started to do this alkene part. Alkenes are called also olefins. Alkenes are called olefins. These are the compounds having double bonds, non-polar, dipole moment is 0, so that only one single intermolecular interaction, that is London dispersions, depends on the molar mass and surface area increasing. Intermolecular interactions are greater. So when the molar mass increasing and the surface area increasing, they are going from gas to liquid to solid. Anyway, you guys know these are odorless and colorless, those simple information. And you guys know we are always focusing more on these chemical reactions. Okay, out of these, 3 different main reactions are there for alkenes. Alkenes are compound with excess pi bonding, so that electron density is greater, so that they are acting as nucleophiles, or they have higher electron density, so that whoever attracts are prone to be electrophiles. So electrophiles attracts double bonds and double bond breaks. We have 4 different kinds of organic reactions: substitution, addition, elimination and redox. Out of those 4, since we have double bonds here, so the characteristic reaction type of alkenes and alkynes as well are electrophilic addition. With the double bond, electron density is greater. Since the electron density is greater, electrophiles are attracting. Other than that, we have other 2 reactions, oxidation and reduction. So under electrophilic substitution, we did bromine, HBr, conc H2SO4 and dil H2SO4. So the very first one is the bromine addition. Inside the medium, when you are having this alkene and bromine, both are non-polar, but with the influence of this double bond, this pi electron clouds, it can induce polarity on this bromine, so that it pushes electron cloud of bromine away from this bromine-bromine bond, so that it gets this partial positive and partial negative. So that partial positive joins with the double bond. So then you are making this condition, but then you get a plus charge on this carbon which is unstable. So make the dative bonding with this bromine, and this delta minus terminal is detaching and gets away, so that it is existing here as Br minus, but here Br plus. Once you given the electrons onto this carbon, bromine gets a plus charge which is unstable, so that it is trying to drag electrons from either side, and so that at the same time these carbons are getting these plus charges, so that this external Br minus is now donating lone pair onto this carbon, so that it is neutralizing this Br plus. At the end of the day, they make this dibromoalkane. So this complex is called bromonium ion or bromocation. This is the most complex one. We discuss everything under the theory class. This is just a revision to remind you guys, this is what we done. At the end of the day, you are making the dibromo compounds. Our medium is Br2CCl4. Br2CCl4. Okay, so after that we are moving to the reaction with HBr. That actually is easier because HBr is having permanent dipole. So the H plus joins very easily, and then Br minus gets away and Br minus joins back with this C plus to make this HBrO alkane compounds. So the middle product is called the carbocation or carbonium ion. But we have a little issue here. When you are having asymmetric alkenes, to which carbon hydrogen goes or to which carbon bromine goes is a problematic. That depends on the carbocation stability. Most stable carbocation exists longer in the medium, which makes a major product. Okay, so let's say this asymmetric one, here you have C double bond C here, and then here you can have then two different kinds of carbocations. To the terminal CH2 primary carbocation, middle carbon here, secondary carbocation. But you guys know through the inductive effect, secondary carbocation is more stable. So this gives the major product. But then, so that this is the major product. So that this is the major product coming through the secondary carbocation. See the carbon, middle carbon is the secondary one joining with the bromine. And here it's to the terminal. But this is little problematic. I mean, it takes time for you to decide. So that the Markovnikov rule is there. What is the Markovnikov rule? Hydrogen joins to the carbon where hydrogen is high. When HBr addition to double bonds with asymmetric carbon. We did a couple of questions. You're going to discuss this next day. Next one is a reaction with conc H2SO4. And conc H2SO4 in the medium mean less water, less dissociation or the weaker dissociation. So H2SO4 as a whole full molecule itself is acting as an electrophile. H plus is joining here. So the rest of this part, SO4 and H. HSO4 minus gets away, and you have this plus charge here to neutralize that this negative charge is joining here, so that your product become OSO3H here. But when you add water, this CO bond breaks, HSO4 minus separates, OH from water is joining here, hydrogen gets away from this water, and that is joining with bisulfate to make sulfuric acid. Here it's acting as the catalyst only. So that this is the reaction with conc H2SO4. Again, it gives the alcohols. Reaction of diol H2SO4 is again greater. Questions, we did a lot of questions. Go through them once you go home. Go through all those questions. Okay, so the next one is with diol H2SO4. With the diol H2SO4, H plus you can dissociate very easily with water. Then what happened is here, H plus is joins first very easily. Then in the medium, we have water and bisulfate. Through the resonance stability, negative charge is moving, but here the lone pair is really localized, so that the donation of lone pair on oxygen is easier. But once you join that, you're going to get the plus charge on oxygen, so that this hydrogen gets away given its lone pair onto this oxygen, so that we are making again alcohol. So the total reaction you can write like this: double bonded compound alkenes, the H2SO4 makes the alcohols. These are the four different reactions. We did questions again. And the next part is the anti-Markovnikov's rule. Thus is to understand Markovnikov rule. Asymmetric alkanes during the HBr addition, hydrogen goes to where hydrogen is high is the Markovnikov. Anti-Markovnikov is the opposite of that, inverse of that. During the addition of HBr to asymmetric alkenes, hydrogen goes to where hydrogen is less. That is the anti-Markovnikov. To understand that, we did question. And then the next part is the oxidation and reduction. During oxidation, remember this very clearly, double bonds are breaking. If you have this kind of situation, one carbon, double bonded carbon joined with another two carbon, that becomes to ketone. No further oxidation stays there. But if you have terminal CH2, that oxidizes up to carboxylic acid up to carbon dioxide. But if you have one hydrogen situation here, double bonded carbon has one CH3 and one hydrogen. So you are definitely ending up as carboxylic acid. If both sides are same symmetric, one single product, but if it is asymmetric, you're going to get two different carboxylic acid. Anyway, remember these are chain shortening reactions. And then the last one, the next oxidation reaction is the Bayer reagent. Bayer's mean alkaline KMnO4, double bond breaks, two OH groups are joining. Double bond breaks, two H groups are joining. And the last little thing is the reduction. We did this one for alkanes, formation of alkanes from alkenes. You can add addition reactions, hydrogen breaking this pi bond to make this alkanes. So the last topic we did was the formation of alkenes. We can prepare alkanes by elimination reactions. HOH gets away when you add conceptual 170. HX gets away when you add alcoholic KOH and heating. Or otherwise, whenever there is a triple bond, you can convert it to double bond by partial reduction with Lindlar catalyst and hydrogen. Lindlar, hydrogen, palladium, barium sulfate, quinoline, that we're going to talk that part under alkynes as well. This is all we did today. Only the main topic alkene we covered today. Because I don't want to stress you guys doing a lot in one single day. We have enough time. So we're going to go slowly, little by little. We have 1 year and another like 10 more weeks for the final exam. So you guys have enough time. After doing this, we did inorganic analytical, which is really challenging. If you still feel like inorganic analytical is disturbing, you're going to start from 3rd unit, chemical calculations. And then you're going to go through reactions of inorganic chemistry. Then you're going to go through inorganic analytical theory. Then only you can come to inorganic analytical questions. Okay, day by day, little by little, never ever give up. We can do this. This is the grand advanced level organic chemistry.